right, this video should hopefully be pretty quick because this worksheet hopefully should go very quickly for you. Symmetry is not too complicated of a topic, so let's just get into it. Number 12. Is it possible for a figure to have reflectional symmetry and no rotational symmetry? Explain or give examples. Yes, it is very possible for that to happen. There's lots of options that you could use to show. One thing that you could use would be maybe an arrowhead shape like this. If I had managed to get it correct here. Let me see. Let me see if I can try that again. Well, it's not going to be exact. But then if I were to draw a line of reflection through it, and if it was exact, you could see that that has reflectional symmetry, but no rotational symmetry. So yes, that is totally possible. Number 13, explain how you would find the angles of rotational symmetry for the figure shown. So first, we have to figure out how many rotations this would be, or how many main petals it would have. It looks like it's got 3 petals on top, right? It's got 1, 2, 3 petals. And then it has other petals underneath, right? It's got like this petal, this one, and this one that are underneath. And it's got some more underneath that. But the actual division of the petals here is going to be through the main middle petals, right? The 3 petals here that go from the center at the top layer out to their edges. So since it's a circle divided evenly into 3, we could say do 360 divided by 3 gives us 120. So a 120 degree angle should return this shape to having another top layer petal in the same spot as there's a top layer petal right now. Okay, let's see. So that would be 120 and then 240 and then 360 degrees. We'll just multiply, right? So we find the angle of rotation and its multiples up to 360 degrees. If a figure has 90 degree rotational symmetry, what other symmetries must it have? It must have 180 degree symmetry. We're using those multiples. It must have 270 degree symmetry again. And then because it has 180 degree symmetry, it also has point symmetry, which is basically just another name for 180 degree symmetry. Number 16, Yumiko's work is shown below. She says the figure is not symmetrical in any way. However, that figure has 180 degree symmetry. It has point symmetry. The figure has 180 degree rotational symmetry, also known as point symmetry. Number 20, how many lines of symmetry does a regular 5-pointed star have? Let's draw them in. We can start at one point and go through the other side, and we can do that 5 times. And one more. There we go. So it's got 5 lines. Number 23, what types of symmetry does this figure have? Explain. Well, It has some reflectional symmetries because we could do similar things. It's got 3 points. So it's going to have 3 points of reflectional symmetry. There's one. I got the angle on that one wrong. Hold on. There's 2. You can see where it should be. And there's 3. So it's got 3 lines of reflection. And it also has a rotational symmetry because if we rotate it 120 or 240 degrees, it's going to look the same as it is right now. We turn it 1/3 of the way around, 2/3 of the way around, it'll look the same. So it's got 120 degree and 240 degree rotational. Of course, it also has 360 degree rotational, but so does everything, so we don't need to write that. Number 24, when drawn in the style shown, the number 808 has horizontal and vertical reflectional symmetry, as well as 180 degree rotational symmetry. What are some other combinations of numbers or letters with symmetry? Find at least 3 other combinations and identify the type of symmetry for each. This is where you can do a zillion things. Please don't copy mine. Come up with your own. So, for example, 33 has reflectional symmetry if you draw it correctly. A number that's any combination of ones is going to have rotational symmetry. So if I just do like the number 11, the number of 111, etc., has reflectional and rotational. And rotational, because we could rotate that 180 degrees, but we could also reflect straight across or reflect up and down as well. I don't want to draw that in, it'll cover up my line. And then, I don't know, there's all kinds of stuff with rotational symmetry. The number 9006, for example, has rotational symmetry. Rotational, and since it's 180 degree rotational symmetry, it's also known as point symmetry. Number 25, how would you decide which flags show reflectional symmetry, rotational symmetry, and no symmetry? So we could just write down which ones have what. So reflectional, which ones have reflectional? Well, Canada has reflectional symmetry. Sweden has reflectional symmetry. And Jamaica has reflectional symmetry. Actually, 2 different lines of reflectional symmetry. There. Rotational. We think which ones are going to look the same upside down. Jamaica will look the same upside down. St. Kitts almost looks the same upside down, but if we turn it upside down, the stars are going to be different because the stars are going to be upside down, and the top is going to be a point. The bottom is going to be this like double star, plus the red and the green will be in different places. So that'd be a none. None for St. Kitts. Number 27, describe the symmetries of each molecule shown. For this one, we are going to ignore the letters, right? C is going to look different upside down. However, that's not what we're looking at here. These are just carbon atoms. These are just hydrogen atoms. We don't need the letters to look the same. We just need the atoms themselves to look the same. So benzene, for its reflection, it's got 6 lines of reflection. Lines of reflection. a line through every point like this, as well as lines through every space like this. Right? It's got more than that, of course. And then it also is rotational by a multiple of 60 degrees. So it's also got 60 degree and all of its multiple symmetries, because if we do 360 divided by 6, we get 60. So 60, 120, 240, oh, I forgot 180, 300 degree rotations. Water only has one line of reflection vertically. One line of reflection. And hydrogen peroxide has no lines of reflection, but it does have 180 degree rotational symmetry. Rotational around this center point there, right? Also called point symmetry. Number 28, which types of symmetry does the figure display? Let's see, reflectional symmetry across a vertical line, absolutely yes. Reflectional symmetry across a horizontal line, also yes. 120 degree rotational symmetry, that's reserved for things with 3 points, right? Because 120 is 360 divided by 3. It would need to be a 3-cornered shape and not a 4-cornered shape. 180, however, we flip it over and it looks exactly the same. So A, B, and D are our answers there. And then 29, which letter can be mapped onto itself with a 180 degree rotation about its center? So if we're thinking the center of the letters, we're going 180 degrees around them. The one that's going to be the same as it was before is the letter N. It's going to be rotated around. It's going to map right back onto itself with a 180 degree rotation. And that is it for symmetry. Let me know if you've got any questions whatsoever, and we can take a look at school.